All right, so we're going to go over the sample test that I have posted for Unit 4. So this is sample test, exponential and logarithmic functions, and here we go. All right, so on this first one, we need to find a function of the form c times a to the x or c times a to the negative x that models this situation. Remember, if the function is an increasing function, then we will use the ca to the x. If the function was a decreasing function, then it would be the ca to the negative x. Excuse me. So, looking at this, we do have the two important points that we normally work with. We have this point 0, 18, and we have the point 154. From our notes, we remember that we will always have the point when we have y equals ca to the x. We have y equals c times a to the x. There are always two important points that we will find on this graph. So we have the points 0c and the point 1ca. So in this particular case, our 0c point is the point 0, 18. So c equals 18. That means, using the other point, ca, we know that ca is going to be the point 154. So our CA value is 54. CA is 54. Since we know that C is 18, 18A equals 54. Divide both sides by 18. And A will equal 3. So we now have that A is 3, C is 18, and so on our sheet, we know that the answer to this will be f of x equals, that's a little bit too bright. The sun just changed on me. There we go. So f of x will be 18 times 3 to the x power. All right, next we have to match each function with its graph. As we look at these graphs, what we need to realize is the difference between a logarithmic graph and an exponential graph. One of the most important differences is that logarithmic graphs have vertical asymptotes, while exponential graphs have horizontal asymptotes. So when we look at this first one, the log 2x, we know that this is logarithmic. So it's going to have a vertical asymptote. So right off the bat, we know that the answer is either B or it is C. Since it is a basic logarithmic function with a base of 2, we look here and we see that, as with all logarithmic functions that have no c value out in front, it contains the point 1, 0, and then it also contains the point where the base, comma 1. So this would be a logarithmic function, vertical asymptote, containing the point 2, 1. So our first one is B. Next, we have looking at y equals 2 to the negative x. Because this is an exponential function, it will have a horizontal asymptote. So in this case, we know right off the bat our answer is either A or it is D. Here we have a negative x. That makes this a decreasing function. Therefore, it has to be A. This is an exponential function. it is increasing. The only exponential function we have left is d. This logarithmic function is flipped over and stretched by a factor of 2. So here we have a function that has been flipped over. It has a vertical asymptote, so that would be C. Tells us to do these without a calculator because these just basically are real quick use of formula problems, understanding what a logarithm is. 2 to what power gives us 8? 2 to the third power gives us 8. E to what power gives us e to the third? E to the third power gives us e to the third. A to what power gives us 1? Whenever there is a 1 here, the answer is always 0. 4 to what power gives us 1/4? That would be -1. Log base 5 of 5, this is just 1. 1 times -4 is -4. It says to use the change of base formula to approximate the logarithm to 3 decimal places. If you have a TI-84 calculator that has the logarithmic feature in it that we talked about in previous examples, then yours can, hold on just a second, there we go. You can hit, to do this problem, the math, and then go to log base, which is A. I have a little problem with my lighting. Just a second. Let's see if I can, there we go. Alright, so log base button. Now we can just put in the base that we've got, base 3. And then a 124 goes there, and we get 4.388. It says to 3 decimal places. Now, if you have an older calculator, what you would need to do is, remember the change of base is log of big divided by log of base. So we could make this the natural log of 124 divided by the natural log of 3, or you could do it log base 10 of 124 divided by log base 10 of 3. And when I put that into the calculator, natural log 124 divided by natural log 3, I get that same 4.388 answer. So either one of those ways works. If you have a newer calculator, you can do it this way. With the older calculators, you have to go that way. Next, we need to expand using the logarithmic properties. Write as sum and differences in the simplest form possible. Write all powers as multipliers and coefficients. So we start with log 3 9x to the 6th. We can break this apart and make it into log 3 9 plus log 3x to the 6th. This 3 to what power gives us 9? 3 to the second power gives us 9, so that piece is just 2. Plus, I can swing the 6 down in front, and that is 6 log base 3x. Next, we have log base 4 of 64 divided by c squared. So in this problem, we're going to use the difference of two logarithms, so the quotient becomes a difference. So we break this down as log base 4 64 minus log base 4 of c squared. 4 to what power gives us 64? 4 to the third power gives us 64, minus, we move the 2 down, so that would be 2 log base 4 of c. So now we have to do these. Now we have to do the same type of thing, only we are doing it in reverse. In that now we are going to combine the properties of logarithms. So here, since it is the difference of two logarithms, we can combine those and make that into log base 3 of 18 over 2, which is log base 3 of 9. And 3 to what power gives us 9? The answer is 2. So now we have negative 2 ln x plus 4 ln y, same type of thing we did last time. I'm going to take that negative 2 and I'm going to swing it up. That's going to give me ln x to the negative 2. I'm going to take that 4 and swing it up. That's going to be ln y to the 4th power. Now, since I have the sum of two logarithms, I make them into one. Ln y to the 4th over x squared.